So hi everyone, today we'll be trying to understand what is hashing method of converting categorical data into numerical feature. So in my previous video you saw that how label encoding has its problems as well as one-hot encoding. So let's try out hashing and whether it is able to incorporate all the problems that one-hot encoding was not able to do. So in hashing we follow majorly three steps. First of all, we take up some hashing algorithm. Now it can be fingerprint algorithm, MD5, SHA 256. These are the algorithms that you can go and read, Google out and read. Now, we for different categories, we feed in these strings into this hashing algorithm and generate an integer value. So basically, a hashing algorithm takes a string and gives you a numerical value. Now, we set up a desired number of buckets. Buckets would represent the total representation we would wish our categories to fall in. Assume that we have 1,000 categories and we set up 100 buckets. So all the 1,000 categories would be represented by 100 values now. So you can see that how we are tackling out high cardinality using hashing. So assume that for if we have 1,000 categories in a data set, we took a bucket size of 10 of 100. Now for every resultant of the hashing algorithm, so in the first step what we did, we took the string from that is a category name into the hashing algorithm, generated an integer, we set up a bucket size, and eventually now using the bucket size we would be dividing the result of the hashing algorithm, and whatever would be the remainder, we would be using it as its numerical representation of the category. So for example, assume that we took some hashing algorithm ABC and we applied it on the string called as New Delhi, which is giving us an output of 1 2 3 4. Okay, now assume that the bucket size that we have decided is 100. So we would be dividing this 1 2 3 4 by 100, giving us an output of 34. Now New Delhi is getting represented by 34 in the numerical representation. This is how hashing is done. Some pros of this particular approach is that it is able to cover all the three problems that we discussed about one-hot encoding in our previous videos. That is high cardinality. So you saw that if even if we have 1,000 values and we set the bucket size equals to 100, so eventually all the categories would fall under that number of that number of unique values only. That is 100. So we have reduced the cardinality. Even also we have reduced strategy for OOVs also. So even if a new string is coming in, we know that the hashing algorithm would be generating some integer for that, and eventually depending on the bucket set it would definitely fall in some of the buckets. So even OOFs are handled. And talking about cold start, so for whichever bucket that particular category goes in, it can take up the features for that bucket. So when the model would be predicting a result using that new category, it will assume it to be similar to the ones that are falling in that category in that particular bucket, right? And eventually it won't be a major cold start problem for this new category, though it is not an ideal solution because the model is assuming this particular category is similar to the ones that are falling in the same bucket, but that is not the case. But yes, at least we are having something. Now the cons being, as I told you earlier, for cold start problem it is not a very ideal solution, but still we have got a solution. Also, when we are reducing the number of when we are taking a bucket size less than the total number of categories, we are assuming that there would be some collisions happening, right? So this is something like for one by one numerical representation multiple categories might be getting represented. So we need to be very careful while choosing the bucket size and hashing algorithm.